Hey there, gang, or konnichiwa, gangu, as we have a Japanese-made Yamaha guitar here from the 1970s. This is a red label FG75. It's not a premium model, but it's nice sounding. Let's get into this. At least twice a month for the last year, so like more than 20 times, people have emailed me asking about neck resets for old Yamahas, and why won't their local repair dude even attempt it for them, and can they send their $500 guitar for me to reset? There's a reason repair people stay away from resetting Japanese necks from this period. For a long time, it just wasn't worth it, and you have to look pretty carefully at the fellow who wants to spend $500 to fix a guitar that's worth $350, because there's a bit of a disconnect there somewhere, right? But these things have started to pick up in value a little bit, and they've got some cachet. They're starting to be appreciated, because they are really nicely put together, even for inexpensive guitars, but especially the upper-end models. They're lighter in weight, and they're more lightly braced than a lot of the American guitars they were copying in that period. So sometimes they sound much better, and they're always fun to play. There's one aspect of construction that really throws a wrench in the works. Until the early 70s, most of these were put together with a standard dovetail and hide glue. At some point, though, they switched over to using different glues. They used epoxy or some other chemical-based adhesive that is, it's not like standard woodworking glue. It's a lot more tenacious. Epoxy will usually soften with heat in our usual neck resetting techniques, but it takes a lot longer, and it needs to get hotter. And usually straight steam isn't enough to do it. So you're there multiple applications over days sometimes. The real kicker, though, regardless of which glue was used, is that for some reason the Japanese builders insisted on putting a generous coating of glue on the front face of the heel, the area that contacts the sides here. They wanted this joint fully glued and locked together, which is something that you don't see in Martin and usually not in Gibsons. It's very difficult to get this whole area hot enough, and there's a lot of surface area there that you have to push free. It takes forever, it's messy, and it's unpredictable, which is the last thing you want as a repair person, because how do you budget for it? Then later in the 70s, a good part of their production switched from dovetail assembly to using dowels. And they had this great system where the body and the neck were sanded together on a big vertical belt sander, using the body itself as the platen. So this was clamped in place, the belt was running up and down here, and they could feed the neck right in there, and it was sanded to the perfect contour to match the sides here, this radius. Very efficient way of doing things. And then they had another machine that drilled 4 accurately placed dowels in both the block or the body and in the end of the heel. So, you know, it was good for them, cost-cutting measure. But removing the doweled necks cleanly is almost a lost cause, because if you get them out there and then you start changing the neck angle, the dowels are not going to fit back into the same holes they were in previously, at which point you've got to plug them all up and then make something like a floating tenon. Very time consuming, perhaps more time consuming than a standard neck reset. Well then, I hear you say, doesn't this make them the perfect candidate for a kung fu neck reset where we cut the neck right off? And yes, it does, depending on which style of truss rod was employed. A lot of Yaris and some Yamahas have sound hole accessible truss rods. They run all the way through here, so we're back to this issue of trying to cut the neck free and running directly into the truss rod. And also, usually these guitars have a housing underneath the top area here where the neck extension is, and you have to sort of cut away parts of the top, and it's a messy way of doing things and very time consuming. To add to that, there are apparently necks out there that were installed using metal pins, serrated or almost like screw threads that would really hold on to the epoxy well, rather than the wood dowels. I haven't seen one of these, but I've heard about it. I'd like to see a picture of someone who's done it or tried to do a neck reset and what that joint looks like. In the end, it's hard to estimate what's needed because there's so many things that could be happening, and it's too much of a risk for both the owner and the repair person. It becomes, well, I'll do it, and if it works, you pay me $400. If it doesn't work, you go home with no guitar. and I'm out whatever length of time it took us to figure that it wasn't going to happen. So no one really wants to be that guy, and that's why all the repair people say, no, not for me. So back to this example here. The action is high. I think the owner said he might have put the saddle in backwards last time he restrung it, and that does seem to be the case here. But even backwards, on the bass side we have more than 1/8 of an inch, 125 thousandths, 8/64ths, 3.1 millimeters at the 12th fret, which is high for most people. Now there's enough saddle here. It functions. The strings aren't running over top of the saddle. Looks like someone has slotted in front of the pins there to get us a bit more break angle, and that's doing fine for itself. Incidentally, I was on Instagram the other day, and a fellow I follow, Cone Tone Guitars, he posted an original Gibson user's guide that included a spec sheet and action heights for all of the various models they were making, probably in the mid-60s, I imagine. The actions we expect today are, in most cases, half the height those guitars were set up with from the factory. We modify the neck angles on some of these old guitars to do things they were never originally expected to do. In some ways, this is sort of what happened to violins in the 19th century when they started pulling the necks off and hot rodding them for modern play. We're in the same sort of situation. Anyway, the relief on this neck is pretty extreme. We're up around 24 thousandths at the 6th fret, which is 2 to 3 times what I would like to see. So hopefully we can adjust the truss rod and straighten the neck out a little bit. We might actually improve the action through that as well. The owner wants me to install a JLD bridge doctor to see if it can lower the action and address a bit of a hump behind the bridge here. Bridge doctors, it's a nicely made device, and it works to correct certain problems of physics that an old guitar can be subject to. Namely, if the bridge is rocking forward under string tension, it can dip the soundboard in front here and also pull it up behind, creating a hump, a bump, or sometimes called the belly. I want to stress something. A hump or a rise in the soundboard back here is a normal thing in old steel string guitars built in the Martin tradition, ones with a flat top or one with very little arch to it. And in fact, if you have a guitar that's more than a few years old and it doesn't exhibit at least some little bit of rise back here, it's probably overbraced, and maybe it doesn't sound all that great. Modern guitar makers have come up with ways to limit that hump by pressing more and more extreme arches into the soundboard, really stiffening it up and preloading it against the stress. However, there's also really good makers, John Graven being one of them, whom I really respect. He contends that by engineering that hump away, you also throw away a good part of the sound that we like in all those old classic models. Those pre-war guitars, they all have a hump there, and they're the ones that everyone wants to sound like. So, looking at the plane of the top in front of the bridge on this one, I don't see a tremendous amount of sinkage there, or dipping, so I don't know how much there is for the bridge doctor to pull up, but we'll see. Yamaha as a business is pretty interesting. They've been around a long time. I know they were making pianos and organs in the 19th century, and they've apparently been making guitars since the 1940s, which is pretty amazing when you think about it. I think the earliest one I've seen is probably early 60s. I don't know what their sort of Japanese production models were like in the earlier years. That'd be fun to have a look at sometime. But, to get from that to also making outboard motors, it's all the same company. And they have a really strong sort of vertical monopoly in the Japanese guitar market. Like, the guy who sells you your guitar, they also own the publishing companies, and they funded a lot of school initiatives, music departments, and that kind of thing. That's a little different. It's not cut for an Allen key, and the size of the nut is larger than you'd find on North American guitars at this time. It's probably like an 8mm or something. And of course, if you were living in America in the late 60s, early 70s, the odds of you having an 8mm socket in your kit were pretty low. So they gave you this nice little slot through there so you can use a straight screwdriver. I snugged it up until it started feeling kind of scary, and we're left with about 8 thousandths relief, which is just fine with me. And with that, the action has also come down to around 7/64ths, about 2.8mm, which is already feeling more comfortable. Before I go ahead and install this, I need to check out the state of the bridge pad, because the bridge doctor screws to it behind the bridge pin holes. In this case, you can see the pad doesn't even extend past the back side of the bridge. It's really narrow, so I'll need to make a supplemental one that will glue on behind it the same thickness to allow me to screw it in. The other thing we can see is this has a kind of oddball bracing system. There are two longitudinal braces that extend from a crossbar below the sound hole. They run the length of the lower bout, and besides this, there are only two tone bars running out to the sides in the area of the bridge. It's a very minimal system. So I'll plane a piece of maple to the correct thickness. Just happens to be curly because it was near the right size. That'll get glued on back here. Okay, let's talk about the bridge doctor for those of you who are unfamiliar. I think I made a video a couple of years ago showing this process, but it's been a while. The bridge doctor itself is a very lightweight piece of wood here. It's probably poplar or aspen or something. And it gets installed inside the guitar underneath the bridge in this area here. It contacts the bridge in two locations. There is a screw that comes down through the top of the bridge. We'll be drilling a hole here, and it screws into this plastic cylinder. The other section here at the front is what bears against the bridge plate, the front area of the bridge. Now, on this block there are three different settings depending on the size of the bridge and the bridge plate underneath. If this was a 12-string guitar, we'd probably use the back hole. In this case, the center setting is just fine. So once we've got that in place and glued down, there is a dowel which goes through a hole in the block, and we adjust that so that this will touch the end block, which is at the bottom of the guitar here. After we've done that, I'll mark it in its location here, take this dowel out, and then cut it off 3/8 of an inch shorter than that marked line. Once I've done that, I can use a set screw. There is a plastic insert here which is tapped for this set screw, and by screwing this in, we can apply force to that dowel, which will basically push up on the front side of the bridge, acting as a bit of a lever. Now, in the case of a bridge that is not, a top that isn't sinking, you just sort of set it there, just taut. But you can also crank up the pressure and really straighten out a top that has a severe dip in it. So it's a good little gadget. It's very light in weight. It doesn't touch the soundboard. The contact surfaces are very small here, so it doesn't affect the sound very much. And even if it does, it usually improves things to the extent where the guitar is much more playable and people are willing to make that trade-off, even if it does change the sound a little bit. So we'll see what it can do for us here. I'm sometimes asked if this device will take the place of or obviate the necessity for a traditional neck reset, and the answer is no in most cases, because the primary reason for high action doesn't relate to a rise in the top back here. More often than not, it has to do with the neck block rotating forward under string tension, allowing the sides and the top to deform in this area, and the neck angle to rise. They're two separate issues. This can have an effect, but not usually big enough to fix a neck issue. It's like a truss rod adjustment. Can that affect the action in a good way? Yes, but that's not the reason we do it. Also, a couple of people have sent me links to a video in which someone has a system that gives you a free neck reset, and it corrects the neck angle by putting some steam in the area above the sound hole on the inside of the top, and then clamping the neck back to increase the angle. And do I think that works? Now, I haven't tried it. In order for it to work, we're told that you have to keep the guitar clamped up like that for weeks, which immediately takes it out of contention for most professional shops. And in my, I haven't done it, but of course I think that if you put the strings on, it's going to be unpredictable. We can't dial in the saddle height the way we do with traditional neck resetting. There's going to be spring back, and in my experience, wood has a pretty terrific memory, and I don't know how long we can expect that kind of treatment to last. If someone has the time to do a bunch of experimentation with it and can prove that the results are long-lasting, then we're all going to stop with the standard neck reset and go to that thing, because none of us really like doing neck resets. But I do know people who have tried similar things, trying to push the body back into shape, and they've all had very mixed results. So the verdict is out on that one. The Bridge Doctor ships with a little pearl dot here, which can be used to cover the screw used to attach it to the body. And this customer wondered whether it might be possible for me to make something that wasn't a pearl dot. Could we use wood? And of course we can. I'll cut him a little plug using a 1/4 inch plug cutter, and we won't have the pearl dot. Now the instructions on this suggest using a hand drill rather than an electric one. And I'm going to start by going backwards here. That cuts a little scoring line which prevents tear out on the top surface of the bridge, or at least reduces it. And we've got to cut in about, well, this bridge is about just over 1/4 inch high, and I'm going to cut this to a depth of about 1/8 inch or so, about half the depth of the bridge. Now I'm using a 9/64 bit to drill the through hole, and I'm going to lighten my pressure up significantly as I get into the bridge pad. I want to go busting through the other side. Steadying things with one hand in the guitar, it's not difficult to screw in the device and tighten it down. Then I can insert the dowel stick and tighten down the set screw. This is a little bit more hard on the knuckles. I'm using regular woodworking glue around the circumference of the hole to hold in the plug, trying not to fill in the screw head, obviously. That fits in very snugly. Here's what it looks like in place on the bridge pad. I'll use a little masking tape to protect the top of the bridge. Then I'll get my flush cutting saw and remove most of the plug that's protruding. Couple swipes with a chisel to remove the little excess that remains, and then I'll lightly sand the whole area. There were a couple of rough spots on the back end of the bridge here which needed some attention. I applied a coat of oil to bring back the shine and hydrate the bridge. Okay, not hydrate, oil drate. And again, there was a little sliver on the front side that needed some attention, so I sanded that as well. And that's what we end up with. You can see it when you're up close, but if you get back a couple of feet, it disappears nicely. The action on the bass side is now just over 6/64. Two of the string slots in the nut were a little bit high, so I corrected those. I'll mark the excess height on the bridge on the treble side, and we'll cut that down using a sanding block. The owner sent along some of these Ernie Ball aluminum bronze strings, so we'll give those a try, or maybe not, as the G string immediately snapped, so I broke out a set of phosphor bronze, and it happened again, which was infuriating. So I got wise and proceeded to file and sand the offending post to get rid of any burrs or sharp stuff responsible for this terrible condition. So we're all set up. In the end, the addition of the Bridge Doctor there helped us lower the action by about 1/64 inch, so 0.4 millimeters. So we end up with about 6/64 for an action. It's 2.3 millimeters, and that's reasonable. It's very playable. It's also about a 25% reduction from where we started, which is great, but you have to remember that more than half of that improvement was due to things other than just installing the Bridge Doctor. In this case, it was just the icing on the cake and got us a little bit more than we might otherwise. And this reinforces my assertion that it's not a miracle cure. You can't put one in just any guitar and expect big changes. Now, on some instruments where the top is severely sunken, the effect can be much more dramatic, and that's where it really shines. This one, it was just sort of a very subtle effect. Anyway, I'll strum a few. It's a nice little guitar. I like it.